All right, so I think this is recording. Let's take a look at these two problems. They are rational equations. I know that because I see fractions, I see variables in the denominator, and of course, whenever I see a variable in the denominator, I have to be concerned about division by zero. So we need to check our answers for extraneous solutions. So let's jump in and take a look at number 3. On the left-hand side, I need to factor this, excuse me, this denominator. With 1x squared, this factors very easily that people should be able to see that x minus 2 times x minus 3. And we see factors of x minus 2 and x minus 3 also within the problem. So sometimes you can kind of guess and say, well, those are very likely going to be the factors. So I want on the left, I want all these denominators to have, all these fractions to have a denominator of x minus 2 times x minus 3. So if I multiply this first term on the right hand side by the number 1, but if I'm clever in how I write the number 1, I can get that common denominator. And the same thing for this second term on the right hand side. I multiply by the number 1, but I write the number 1 as x minus 2 over x minus 2. So now I have a common denominator to all of these terms. If I multiply all of these terms on both sides of the equation by that common denominator, these denominators all cancel. And we have 3 is equal to x times the quantity x minus 3, x times the quantity x minus 2. However, when we do that, when we multiply both sides of an equation by a variable, we introduce the possibility of extra solutions. And if we get one of those, we refer to it as extraneous solutions. So in factored form, I can see that I can't allow positive 2 to be in my solution set because this original equation would not check. That would be 2 divided by 0, and that's undefined. And I can't let 3 be in the solution set. Look at this second term on the right-hand side. It would be 3 divided by 0, and that's undefined. And you can't add that to something that you have it equal a real number. So I have to be cautious and make sure that those don't appear in my solution. All right, so this is a quadratic equation. So let's work towards getting it in standard form. First, we're going to have to apply the distributive property. We get x squared minus 3x. Apply the distributive property again, and we get x squared minus 2x. If we get this side equal to 0, with x squared and another x squared, we have 2x squared. With our linear terms, we have minus 5x, and now if we subtract 3 from each side, so with a leading coefficient different than 1, sometimes this can be a little more difficult to factor, so we have a choice here to look to see if this can factor or to use the quadratic formula. Let's look and see if this does factor. We'll use our x method. We've got our middle term goes at the bottom of our x, and if we multiply the first term times the last term, that goes to the top of the x. And now two expressions that multiply that give us the top but add to give us the bottom, I believe just our negative 6x and 1x should do the trick. So now if we put this information in the form of a table, the table is just an organized way that helps us to apply the distributive property. 2x squared minus 3, and then we have negative 6x and 1x. So if we look and factor and put our common factor on the outside of the table here, we get a negative 3, a positive 1, an x, a 2x, and we can multiply and check and see if we haven't made a mistake. 1x times 2x is 2x squared. 1x times 1 is 1x. Negative 3 times 2x is negative 6x. And negative 3 times a positive 1 is negative 3. So it looks like we've done it correctly. I need a little bit more room. All right, so what this table has done for us is allowed us to rewrite this trinomial as a product of 2x plus 1 times x minus 3. And so this is going to give us solutions of negative 1/2 and positive 3. But I can look up and I can see that I made the remark initially at the beginning of this problem that if x equaled 3 appeared in this solution, if it was a solution to this quadratic equation, it's not a solution to the original equation. This guy is referred to as an extraneous solution, and our only solution to this equation is x equals negative 1/2. All right, so I hope that helps. Let's take a look at number 4. Should be very similar. We look on the left-hand side and we see that we have different denominators, and on the right-hand side we want to factor that denominator. So I've got x plus 3, 2x plus 3 over x minus 1, and I have 2x minus 3 over x plus 1. Hopefully I didn't say x plus 1 just a second ago. I may have. And then here on the right-hand side, if I factor this, it factors to x plus 1 and x minus 1. So that's the denominator I want in all of these fractions. So in this first term, to get that, I'm going to multiply by x plus 1 over x plus 1. And now this first term will have the correct denominator. And on the second term, if I multiply by x minus 1 over x minus 1, it will have the correct denominator, the denominator that I want. All right, so now that every term here has the same denominator, I can multiply this equation, all these terms, by that common denominator. And the only thing that I'll have left is the numerator, the operations in the numerator. So I'll need to multiply 2x plus 3 times x plus 1. I'll need to multiply 2x, excuse me, minus 3 times x minus 1. Now, I need to stop and slow down for a minute. When I multiplied both sides of this equation when I multiplied all these terms by this common denominator, I could be changing the solution set to the original equation. And so I have to make sure that when I get the solutions to this quadratic equation, that I don't claim that x equals 1 is a solution to the original equation, because that would cause division by 0. And I also have to throw out negative 1 for the same reason. So let's solve this quadratic equation. We're expecting two solutions, and let's hope that they're not either one of these, or at least if they are one of these, recognize it, call it extraneous, and throw it out of the solution set. So if I multiply these two binomials together, you may choose to do it in the form of a table, or whatever your favorite way of applying the distributive property is. But what you should get is 2x squared plus 5x plus 3. Now with this minus sign, I'm going to put parentheses around this trinomial, because after I multiply these two binomials together, I'm going to have to subtract every term, not just the first term. So if I take 2x minus 3 times x minus 1, I get 2x squared minus 5x plus 3, and that equals 10. So I have, well, write this out. Let's not take too many shortcuts. When you're subtracting, it just changes the sign of every term. So I can see that 2x squared minus 2x squared, that this actually cancels. And so now I'm not expecting two solutions like I was when I first looked at the equation. 5x and another 5x gives me 10x. And the 3 minus the 3, those cancel. And so here this 10x equals 10. And this is leading me to believe that x equals 1 is a solution. But remember, that can't be a solution. That was one of those values that we said that we would call extraneous. But it's the only candidate. So with this out of the picture, my final answer is that this equation has no solution. All right, so I hope that helps, and I will talk to you later. Ask questions if you get confused, or let me know if I've made a mistake in any of these videos. That way I can edit them for other people. Talk to you later. Bye.